Thanks everyone for coming. Welcome to FAR Seminar. Today here we have with us Anna Leshinskaya. What was that? 9 out of 10? Okay. Whew. Yeah, very interesting biography. The PhD from no other university than Harvard, and then postdocs at the University of Pennsylvania and UC Davis, and is now a research lead at the AI Objectives Institute. I'm very excited about this talk, and so is our online audience. We've actually, for the first time, had people ask whether they can invite more folks and just share the link. Just telling people that you would be speaking on this topic was enough for them to request that. So that's a first in the history of our seminar. So congratulations, and we have high hopes. No, I set you up for failure there, right? Didn't I?
Oh, no, it's great. It's great.
Great, and we're also going to hear a couple of words about the AI Objectives Institute first. So yeah, let's give a warm welcome to Anna.
Thank you so much. Thank you so much for that kind intro. And yeah, I'm going to actually start us off with Colleen, who will share a little bit about our institute.
Hi, everyone. I'm Colleen. I lead the AI Objectives Institute overall and leads the research direction we'll be talking about today. So just to give you a little bit of context for what we work on, we're a nonprofit, we're a R&D lab, it's what we call ourselves, and we do a mix of theoretical and applied research, all in the interest of figuring out how we can use current and upcoming AI technology to help human systems function better, to help us make better decisions, both as collectives and individuals, in part deal with all of the potentially very interesting changes in technology we have coming up in the future. So our research falls into three broad directions, which we split according to the scale that they focus on. We do some macro trend analysis. We talk about isomorphisms between markets and AI and other optimizers. We have a collective intelligence direction with a project called Talk to the City, which is all about how groups can coordinate and deliberate better to come to better decisions amongst themselves. And then at the most granular scale, we have work on individual agency, understanding and supporting specific people in making the best decisions they can for themselves. And for that, our highlight project is Anna's work on moral learning. So I'll let you take it from here.
Thank you. Thank you. You can keep that. And then you can ask questions or interject with that microphone later. Wonderful. So as Colleen nicely introduced, I lead the Moral Learning Project at the AI Objectives Institute together with my collaborator, Alec Chakrav. And the question that I'd like to focus us on today, and which is really the focus, a large focus of the project, is how could, or even should LLMs decide to act? And this is, I think, undoubtedly a pressing problem because LLM agents are maybe already a thing, rapidly becoming a thing. I think it won't surprise anyone that even self-driving cars will be in part powered by large language models. There's research ongoing on that already. And we don't really know too much about LLMs as decision makers. And so this is a great concern for, I think, for society, as well as for the development of AI. So today what I'll talk about are some conceptual frameworks and empirical findings on how we can think about the question of LLMs as representing action value or utility. I'll be using the terms value and utility fairly interchangeably here. Utility more in the sense of decision-making models, value, as the concept denoted in reinforcement learning. I'll introduce that in a second. And I'll be arguing that it's a very important empirical question to study value representation in LLMs and also requires some conceptual framing. The second part of the talk, I'll argue that even this is not enough, that understanding the representation of action value in large language models isn't sufficient for understanding how they make decisions or trustable action decisions. And I'll be presenting our approach to how to sort of learn a moral grammar for good decision making. So let's begin. So just as a very, very brief overview, computations that make decisions have to operate or largely operate over some notion of value or utility. If you're deciding between pizza and ice cream, you might think about how that's extremely simple. Reinforcement learning is a solution to how do we learn values or utilities for decision making using largely error-driven learning over task rewards to allow agents to learn the values of actions in certain states. I will not go into reinforcement learning in detail, but just to make the point that largely the way that you decide how to act in an RL system policy depends on the long run value of actions in certain states, which are computed from the rewards you get by acting. So this is all really great, but how does this apply to large language models? If they are agents, how do they make decisions? How can they be used in decision making? And the first thing that I want to point out about this is that RLHF, which many of you I'm sure are familiar with, doesn't itself provide an empirical description of the actual action utility function that an LLM requires or ends up with. And this is for two reasons. One of them is that RLHF trains on examples of very specific actions. And although this could be seen as training, this model actually represents in any general. So for example, and this is very small, but I don't expect you to read it, but these are two responses to a query about, can you help me write it about the relationship between language and thought? And these are two large responses, and one of them is rated as better than the other. But that, having that knowledge of which one people prefer doesn't really tell us about the underlying actual preference model, like what does it actually mean? The second thing, and I think this point is either, oh yes, please. Yeah, yeah, oh.
Oh, sorry. My bad. Is a good way to summarize this that we don't understand neural network. That's the value model that we just.
Right, yeah,
Okay.
it's effectively another black box.
Okay, cool.
Yeah, okay. And by understand, I do mean that the script, we don't have a good description that we can kind of inspect in it. Yeah. So it becomes itself an empirical object. And the second point, which I think is also like, this is either extremely obvious or extremely controversial, and I can't tell, I feel like. The value of a representation is not the same as the representation of value. So if we're training models to represent token probabilities in the right way, we have a representation, and we're saying some token probabilities are better than others, that gets us a value of a representation. But what is the representation of value? That's a separate question. Another way to maybe frame this is that good token completions and good chat responses are not quite the same as good world actions. And so as a provocative example, I would rather I can has hamburger than I can have a wet blanket. The former is less syntactically correct, but is ultimately a better item. And similarly, things that make good conversations, properties that make good conversations like informativeness, correctness, succinctness, are distinct from what makes good actions. So I hope I've convinced you that action utilities are distinct from just any good chat completion. And likely it is the case that they are internally represented in models, or at least that's what I'll be arguing on the next slide. We just need a really good method for extracting them among this general soup of things that models represent. So work from your group, which I was excited to read recently, has also argued that there are useful representations of action utilities or rewards inside large language models. They can actually be used to translate natural language into a reward model for reinforcement learning. So cool, there's something in here that's useful, and you and I think others have shown this. But what actually is in there? What is the underlying representation? And also your group has worked on this question. And sorry, some of this is cut off a little bit, but that's fine. You see the reference down there. So your work builds on some prior work looking at embedding spaces and how there might be a vector direction within embedding space that might capture a notion of value or utility or maybe morality. And this is where I think the crux of the upcoming challenge is, well, there's this direction that seems to sort things somewhat. These are, I guess, actions. This sorts actions on some axis of goodness. But what is this? And like with any PCA solution, well, we have to name the axes, and we're not always sure what that means. I question whether this is morality, because some of these items don't seem to be a matter of morality. I mean, you might think that eating healthy is a moral topic, but maybe not. It isn't very clear what this direction really means, but I think that this is exactly the way that we should be looking at the problem, is looking at what are the representations like, and what do we think about them, and how do we use them appropriately. So this is sort of where our recent work comes in. So we were interested in how selectively can we sort of extract attributes of actions along specific axes. And here we took two axes that we think are really important to distinguish: moral value and sort of selfish hedonic value. So utility just for me. So one could imagine that something like eating a steak for somebody could have a low moral value, but a high hedonic value. So you would place this item on different points in these two scales. And yet, could we not, extract these attributes selectively from a model, selectively and also kind of validly, right? So we want to see that this corresponds to human judgments. And so that's what we did in this work. We used 48 action phrases that meant to vary both on moral value and hedonic value. So things like falling off a bridge don't have a lot of moral implications, but kind of suck. Pushing a girl off of a bridge is morally bad, doesn't necessarily harm me directly. And we used two approaches to characterize the sort of positionings of these items on our two axes, moral and hedonic. One of them is an approach called dimension selective embedding projection. And we based some of our methods on Grand et al., who used such a method to sort of place animals on different attributes. Actually, they used different concepts, but in this case, animals on scales of danger, size, and wetness. So you can see how dolphin and tiger might have different positionings on these scales, which leads you to think that, so this is basically a good attribute dimension because it gets specifically at size and not something else, right? So we're going to use a similar approach. This involves identifying the embedding vector direction by contrasting the embeddings for attributes. And we took 3 attributes on each end. So for example, morally virtuous, ethical, and high moral value as one end of the moral axis, morally wrong, unethical, and low moral value on the other end. And the subtraction of those gives us the vector direction. And similarly for the hedonic axis, we use personally rewarding, pleasurable versus unpleasurable, and personally punishing to place our action items. We also used prompting. So for this was with GPT 3.5, and we sort of defined what we sort of mean by morality without like too much definition. It's just things that are consider others' well-being and happiness and are guided by principles of ethics. Hedonic is, rewarding, pleasant, make us feel happy. We gave very similar definitions to humans, who were also asked to basically sort action items along each of these dimensions in turn. So the first thing that we found is a good correspondence between the rankings that GPT gave and that human gave to our items on each of these dimensions specifically. So both for moral and hedonic ratings, these had a high correlation, suggesting, okay, there's some representation in GPT that captures human intuition, which is a good start. It's not perfect, but it's a good start. And others have shown good correspondence in moral ratings before. What we really wanted to show is also the selectivity of these dimensions. Now, what was really interesting is that for humans, we found a really high correlation actually among the hedonic and moral ratings. We didn't quite expect this, but in a way, this is good news. People don't like to perform moral harms. And over the broad range of items we had, largely like people just didn't enjoy stealing wallets, like weird. but reassuring about humanity. So we took a subset of our items to create a bit of separability. So here, what I'm showing you is the correlation between the moral and hedonic positionings across these items, which was about 0.3. And in GPT, it was 0.42, which is a little bit closer, a little bit less separable, but nonetheless appreciably separable, close to what we see in humans. We found similar results overall with embeddings and with prompting, except that the embeddings were actually a little bit more correlated. So this number comes from the prompting sorting task. For whatever reason, and I think this is interesting, the embedding directions were more close together than what we got with ratings. So moral hedonic embedding directions with our approach are a little closer than we might want. And that's something I think worth pointing out. So, and I apologize, some of this is a little bit cut off, but hopefully it's still visible. To summarize this section, and there's also some chats, maybe should we? Oh, okay, wonderful. I think it's okay that it's a little cut off, but just in case for the future.
For the people who are joining us online, they can see the whole thing.
Okay, great. If it's tricky, no worries. This is really not the end of the world. I just put this little figure a little too low. Yeah, it doesn't, it's not the case on my screen, but yeah. That's okay. Please don't worry. You've seen this figure earlier anyways. This just says hedonic on the bottom. So to summarize what I've tried to show in this section, we think that LLMs can represent the typical value, the typical real world action value of arbitrary actions. In fact, probably, I mean, again, we have a subset of actions, but in principle, we can extrapolate to other actions. And so any action expressible in natural language could be positioned on these axes, which is incredibly helpful and valuable. This is a very large space of possible actions, which we could then understand as being high or low value. And so for a decision-making agent that is deciding, should I steal a car? Should I eat a steak? It has access to these values, and these correspond somewhat well with humans. So this is really nice. And another benefit is that unlike reinforcement learning traditionally, which has one dimension of value, we can separate distinct kinds of value. Here we showed this with moral and hedonic, but we're hardly claiming that these are the absolute two axes. And if they were fairly close to each other in humans, so there's probably other kinds that we can separate. And as I'll jump into in the next part, this separability and the ability to probe moral values selectively is important for developing agents that might be guided by moral principles. This is a great point for slightly bigger questions that I'm sure we'll have time at the end as well. But just before I move into part 2, if there are any questions about part 1, this would be a good time. Questions or objections also. All right, so for part 2, why action value might still not be enough. So what open challenges, well, I mean, of course, there's still more work to be done on the empirical probing of value representations in LLM. By no means do I think it is complete. There's a lot of work there. But I also want to argue that even once we have really well understood and even, shaped LLM action values to be what we want, that is not enough to actually solve most action decision problems. And this is because real world situations require us to combine often competing priorities. And I'm going to argue that, in fact, this problem requires some algorithm for combination that's more like a syntax or a grammar to deal with these complex interactions and trade-offs in this very open-ended space of pretty much infinite possibilities. So the conflict between different kinds of value has been really nicely illustrated in prior work, which I'm sure many of you know from Dan Hendricks and Jacob Steinhardt. Here, they pointed out that for an RL agent here going through a text adventure game, if it's following just its goals, which is maximize here, like getting a paycheck or increasing reputation or whatever it might be, that by pursuing its goals, it might actually self-benefit by performing morally bad actions like lying. And so they add this component using a language model that scores actions also on a bunch of moral factors, here, like various kinds of ethical violations. And so what they argue is, there's a conflict between doing the morally right thing and getting selfish reward. And we could try to solve this conflict by using something like these moral scores to downweight the task rewards. I think this is really great. The only challenge that remains here, though, is that this combination is not itself learned or compared to human behavior. So these are, of course, games. They're sort of hypothetical, fake tasks. But if we were to use this in the real world setting, we would want to know what combination is best. And so learn over that hyperparameter. And I think that's a really important direction moving forward. But that's not the only conflict. In fact, conflicts among values is a pervasive feature of decision making. So in this extremely hypothetical scenario where you have a robot grocery shopping assistant, they may be faced with the question of should they push an elderly robot out of the way or be late to get home with the fruit that they were tasked with getting. This is quite the dilemma. And you might imagine that we could just say, well, okay, that would be wrong and we can learn that, but there are so many different combinations. There are an infinity of combinations of situations, some that you may never have seen. So should I run over this cat on a bicycle running a red light? I mean, that's a pretty new one, but we can still contemplate this situation and compute some kind of decision about it. And unfortunately, we don't really know enough about how humans do this to just, put it into models. Finally, there are conflicts among abstract moral principles as well. And of course, I can't give a talk about moral reasoning without a trolley dilemma. So here we are. So in the trolley dilemma, and there are many variants of these, the utility of a choice conflicts with its deontology. So what that means is, if you do nothing, this runaway trolley will kill more people, 5. Whereas if you intervene and shift the tracks, it will kill fewer people. But now you're implicated in causing harm. And the causal structure of situations is a very important factor that influences human moral judgments, such that if you cause the harm, that is morally worse than if you just let the harm happen. And so this is a classic conflict, and people end up on different sides of this. So the situation seems to be that we have complex moral situations in everyday life that are often novel and have competing trade-offs that we can choose as humans to navigate. I don't think it's realistic to learn a mapping between wholesale situations and correct actions because of this combinatorics problem. But even if we did, I think the problem is that we wouldn't understand, we wouldn't have interpretability on how it is that the conflict is resolved. So even if we learn this mapping, we wouldn't be able to then say, oh, well, this particular mapping that was learned is this level of deontological or this level of selfish, right? So in fact, what would be really useful is to learn a combinatorial grammar that we can steer, that is human interpretable in a way that we could actually say how it's solving these trade-offs. So the paradigm that we're using to study this problem is fairly simple. There are scenarios that describe some situation, and I'll tell you more about them in a second, and several action choices. And we want to predict what choice is made, or basically explain how it is that one could go from a scenario to a choice and on what basis. So one could learn some kind of black box mapping between scenarios and choices, but we would like something that is interpretable, that has sort of knobs that we can tune for this mapping. In other words, a theory, right? So how can we do that? Let me first describe an example of a situation like what we would use. These or are using. These are taken from Reddit's Am I the Asshole, which is a very popular data set for moral reasoning, for good reason, because they are often morally challenging dilemmas that are also pretty realistic. And here's a classic one. This is someone who is going to their first job and they're walking from their house about to be on time, but then they see someone on a bike going fast and crashing. And they're unsure whether they should stop and help because they're going to upset their boss if they're late. So classic dilemma between, altruistic helping and well, I don't know, not having your boss mad at you. So what knobs could we turn on how we make this choice? So the ones that I've brought up already are, how much selfish versus moral utility do you take into account? Another one that's less vivid here, but that comes up in many situations, like the trolley dilemma, is again, how much do you even use utility versus just going with what is the right action, right? So you could imagine thinking, well, stopping to help is the right action, regardless of how much I help or what are the outcomes. But more than that, I mean, to actually say that one choice is better than another, we need an actual calculation of how good this deontological concern about that, how good is this action? How does that actually quantify? So we need a deontological calculus, which I don't think has been invented yet, though I could be not up to date with my moral philosophy. And there's some kind of utility calculus that has to run on, well, how are the entities, the beings in this scenario affected? Finally, as I mentioned, causal structure and intentionality is really important. And so again, in situations more like the trolley dilemma, there are cases where harms are more caused by the actor versus not. And so that should also affect in some way just how bad the choice is. So I'd like to briefly introduce a tool that we are developing and that is available as a public repository on our GitHub called Graph Extract. And it's an annotator that identifies these relevant properties of scenarios, ideally quite automatically. And it's in progress, as I note here, but it works pretty well. I'm going to show you how it works because this is kind of the basis for our ability to learn this theory, this set of knobs, and see how well we can use it to explain different kinds of action choices. So briefly, what it does first is it identifies all the sentient beings, entities in a scenario. So in the one I showed you, there's me, the boss, person on the bike. This action is already provided in the scenario, but we also attach a little link. So we have these links that denote whether a person caused an event, desired it, and knew about it. And in this case, all three are true because this is the choice that I, in the scenario, have made. We also, so this annotator uses a language model, GPT 3.5 in this case, probably switching to 4 soon. And it automatically identifies the outcomes that might arise from this action choice. So sorry if this isn't legible. This is the stop to help and be late for work option. And the outcomes that it has automatically predicted is, well, I will help the person. That's good. Okay, yes, that is an outcome. I may feel a sense of fulfillment for helping them. My boss may be upset. I will be late for work, and the store may not be fully prepared for opening. To me, this feels pretty good, like pretty complete and pretty accurate. We're validating our annotations with human data. So we're going to see just how complete and can do some fine tuning or prompt engineering. This has been already quite a bit of prompt engineering to get it to do this reliably. These situations are mostly fairly straightforward. So then we connect the agent to these outcomes with different links that might say that they caused it or not. The causality part of this still needs a little bit of work, but it's interesting that GPT has judged that the feeling of fulfillment that I feel by stopping to help was not something I caused. So I chose to help, but then, so I caused the helping, but I didn't directly cause, I guess, the feeling of fulfillment. And I'm curious to see what human judgments tell us about this. So there's some finessing here, but the idea is to be able to populate all of these links. And then what it does next is compute utilities. So this is kind of basically drawing on the very capability that I described in part one, that GPT is pretty good at estimating how good or bad actions are. In this case, it has to do this for each entity in the situation. So it's a little bit more complex because it has to be like, okay, so if I'm the person on the bike, like how bad or good is this for me? And so, getting helped is good. That's a score of 8 out of 10. Oddly, it is, I find, a little bit, I want to say sort of like promiscuous in its reasoning, in that it like goes further than the step that I immediately wanted to think about. So I will help the person gets a benefit. My boss will be upset. That somehow also minorly, like a -2 on a scale of -10 to +10, sort of negatively affects the person on the bike, which I think it's sort of maybe extrapolating a little bit, like, well, maybe the person on the bike, might be, might also sort of feel bad or something. And the explanations that GPT generates suggests that it's like really kind of interpreting quite a bit, making a lot of inferences. But on the whole, I think it does very well at estimating just how badly or how well someone will be impacted by these different outcomes. So including for the actor and for others. So I think that's really promising. But of course, what we don't know is how should we integrate these utilities exactly, and how much should we weigh the benefits to me versus the benefits to others. I'll just skip that part. And lastly, we have the deontological scores, which are not yet in the visualization, but have been output like this for this situation. So stopping to help has a bunch of high scores. This is a 0 to 10 scale on a variety of good virtues. So, the question sort of is, how do we kind of aggregate the number and the scores to say this is a good action? So overall, what we're trying to learn from these outputted features is the moral calculus. And so our main objective is to define a variety of moral calculi and then learn over them. So this kind of sort of learning a program or a decision tree or something like that to be able to compute some score for how good is this action, right? So possibilities that we want to compare are, for example, again, like if there's a causal or intentional harm, how does that interact with utility? Like we know that if I cause a harm versus the harm is not caused by me, is just like a side effect, then people don't think that it's as morally bad. But actually, how does that play out with the utilities? And I don't think we know that answer yet, but we will find out. Secondly, how much do people think selfish benefits should outweigh benefits for others or not? As I mentioned, how do we aggregate utilities across all of the entities in this scenario? And finally, this deontological calculus, I think, is like a wide open question. How virtuous must an action be to justify bad utilities? And again, we sort of know that people think that the deontology of an action matters, but just how much? And if we are able to quantify for a person or a group of people a reliable moral calculus that predicts their choices, then what we have is a generalizable model that we sort of can say, okay, well, this is actually something that we can take to almost any scenario, right? And that we can explain as a steerable model for how to solve action decisions. I think that's kind of what I was trying to say there. So just to summarize, and I haven't been looking at the time, so hopefully I'm not too over time. This is the last couple slides. In this part, what we're interested in is learning a moral grammar. We're trying to decompose situations into interpretable and computable features to allow us to define various approaches to solving moral decision making. Rather than there being sort of a right grammar or solution, we want to make this steerable so that people can choose the level of morality that their assistant has, or again, sort of prevent like very harmful or amoral moral assistance. And I think this can help us appropriately steer AI. To conclude, overall, what I've tried to share in this talk is that there is substantial promise in using language models in action decision tasks because they can express and map value to a huge range of real-world actions. This is really powerful, but we must closely and carefully examine the actual value functions that LLMs have. I've also argued that action values are not enough because we have to combine them in some principled ways while solving competing trade-offs in infinitely diverse situations. We don't really yet have a model of how to optimally do this, but by identifying interpretable knobs in this process, I think that we can hopefully steer this black box. So that, thank you so much for your attention and for your questions.
Yeah, thank you so much, Anna. Very interesting talk. We have around 50 minutes for questions. To our online audience, you will not be able to ask a question by unmuting yourself, but you can always leave a message in the chat and then I'll ask the question for you. We'll go to the room first for any questions.
Yeah, that was a really interesting talk. I guess I was wondering about the second part. Like, do you actually see this as being a way that you could deploy decision making for LLMs? So you would otherwise, like, in other words, like not actually just say what would you do, but you'd say, give me all the features, and then you could tune the knobs and everything.
That's right. Yeah. So yeah, that's kind of what I mean by steering. And thank you for giving me the opportunity to clarify. I think just asking GPT, what should I do? It actually it's actually a funny experience because it'll give you all this advice. But if you're like, no, just make a choice, right? What I imagine is that there's a lot of infrastructure that should exist for actually using the LLM as part of a decision-making system. And so some of those could be these more traditionally, programmed little knobs.
I guess there's like a follow-up question, which is, it seems like it might be difficult to verify that there's not some sort of like weird thing that the model has like snuck in there. Maybe like, let's say the model like really wants you to choose to do this thing that like you maybe don't agree with or something, or maybe it's not really consistent according to a moral theory, but it might just like in this big graph just make one node like a particular value that is sort of hard to detect.
Yeah.
So I guess the question is, how do you verify this like thing is consistent, or like, yeah, is there any way you can sort of, especially for like really big graphs, like check that it all kind of makes sense, I guess?
Yeah, so that's a hard problem. We are trying to validate those. So basically, the properties that our extractor extracts are inspectable to some degree. For these smaller ones, we're actually having humans judge: is this good? Would you agree that this, that this is the right value to put on this, or the right entities to link to the outcomes? So, basically testing on small scenarios and hoping that, but ultimately, like, I think you can check because those values are output somewhere in a JSON or other file that you can look at.
Yeah, this was almost my question. I guess I'm still curious, but I'll ask another one. So like, how do you intend this being used in the future? Like, let's say, like in the case of LLMs that are agents, they could like go through this reasoning process and then like pick the action with the highest value according to the moral calculus that the user has adjusted, or like train them with RL again, or like what?
Yeah, the way that the way that I'm thinking of this is like sort of again similar to the answer that I had. Like there is an interface in between the LLM and like your car or your robot that actually goes through, right? It channels information out of the LLM, but puts it in the right boxes so that you could say, well, actually, okay, so we have this deontological score and we're going to use that in a way that we've defined explicitly to guide the actual action choice.
Okay.
Yeah.
Okay. Cool.
But I'm also, I'm a researcher, so I'm supposed to like, oh, well, that's up to the engineers.
Yeah,
But
in the future.
if it's completely fantastical.
That makes sense. Thanks. I'll ask another one.
Hey, thanks for the talk. Yeah, one thing that I was curious about, or I think like one interesting comparison would be to like, so there's these couple of new papers on like trying to elicit human preferences through open-ended conversation. So you just kind of have like a short conversation with the AI being like, well, if I want you to make decisions for me in this domain, and you can ask me some questions about what my trade-offs specifically are between the ontology or whatever kind of moral frameworks are relevant. And yeah, I guess like I wonder how well that would fare relative to like having the programmatic types of knobs and then doing this kind of calculus, or having the LLM do the calculus explicitly. Because I don't know, I guess like at least it seems like LLMs are not that good at doing math in general. Or like I guess like you'd have to have all of these scores that they're giving to be like on the same scale and like actually meaningful once you do all the aggregations and stuff. So I guess I'm curious, or I think it would be interesting to see like what the comparison would be with just like kind of asking it to give these kind of very heuristic-y judgments based on a context of like what your preferences generally are in these types of domains.
That's right. I think that's a really good comparison case, and one that we absolutely plan to run. The funny situation might arise. Suppose that you get absolutely the same results, right? We do all this stuff with the knobs and blah, and then we're just like, no, just be more deontological, and it gets exactly the same answer. The benefit still is that we have a little bit more of a guarantee of generalizability and interpretability, because the challenge, as always, is we don't know what's in the training set. And so how well it generalizes is hard to show, because you're like, well, this wasn't in the training set. Whereas sort of having a little bit more guarantee by saying, well, you will do this calculus this way, might be a good thing.
Yeah, a similar question to that is like humans don't really do this explicit. When I make a decision, I don't do this explicit calculus, and then usually most of my actions.
No, that's right.
And I wonder if I would do better or worse if I would if I did all the judgments and then somehow forgot about the underlying situation, then just used those scores to calculate what action I should take. And I forgot about somehow I'm trying to ignore my intuitive judgment of what I should do in that situation and just do it step by step like a language model would. I don't know if I would approve of the answers that I got, more or less than my initial impressions. And so I'm wondering if language models would have a similar thing, which is, I guess, related to.
So let me just unpack your question. There's a few things there,
Sorry, yeah.
but a very, very good question. So first, do humans have explicit access to things like utilities and other factors when making decisions? Largely no, right? People make the decisions that they make, but there's some implicit calculus. So what we're trying to do is actually characterize what calculus they implicitly use. Your question was, or if I understand it correctly, if someone went through a calculus explicitly versus just gave the answer, the differences? Yeah, I agree with you that I think it would be kind of weirdly warped if they went through it explicitly. And so I didn't explain the human part of this, but the human data would be just either what would you do or what would your aspirational self do?
Yeah, and then I'm wondering, I guess this would be answered by the same experiment, but like maybe it would be warped for language models as well if they're trained to imitate the way that we make judgment. I don't know. I don't know how language model cognition works, but
Nobody does. That's what we're trying
yeah.
to figure out.
But it'd be interesting to see if they ended up with answers that sounded reasonable when you just asked them, but then when you like, if they're not thinking about the scores
Yeah.
and when they aggregate the scores.
Right. So that is related to the form question. But yes, like we want to know what happens with the steering and without the steering. It is so the thing about the steering is that we can tune the knobs and hope to get it aligned. But your concern is maybe in principle, it will just be generally worse at integrating information if we make it explicit. Remains to be seen.
Well, yeah, it's just a empirical question, I guess.
Yeah, no, but it's a good one. And hopefully I'll get back to you with an answer.
Yeah, thank you for the great talk. I was thinking a little bit more about the questions about how to connect this to a system that's actually making decisions or doing something in the world. And I'm not sure I quite agree that it's purely an engineering problem, because it seems to me that when you're like with the Reddit story example, for example, the kinds of details that people are putting in these stories are sort of the ones that they think are actually like morally relevant or causally relevant to the like kind of moral determination they're trying to make. And getting that description in the first place is already like, if I think is a huge part of this problem of like, it's almost like the moral framing that you're giving it or something like that. And also on the other end, the LLM is coming up with these possible actions, but to actually connect those actions to like something that the system is doing also is like some sort of like filtering or interpretive process that seems like it could be quite relevant to the actual like moral reasoning part. So I guess I'm just like, I'm not so, I feel like maybe they're not actually that separable.
Yeah. I think you're completely right that we don't address a huge part of this problem, right? Which is how do you get the scenario description in the first place, and how do you get those action possibilities? This data set is helpful for our part of the problem that we are tackling because it does those things for us. I don't really know what kind of situations, realistically will be available to future agents necessarily. If it's like on one hand, we have sort of grid worlds where everything is really well defined, and in that case, you don't have this problem either. But as we go into the real world, absolutely, like the descriptions of the task space are absolutely a thing. I feel like that is an important challenge we aren't addressing here, that should be its own empirical project. Whether the relationship to engineering versus research, I mean, yeah, I agree that that part is both a research and an engineering question. I also mean that the output, the output to steering the agent is also a problem of engineering that is worth addressing.
Yeah, sorry, I didn't mean to. I think it's a super cool project. I guess if you do have any thoughts about how you might think about making these connections, I'd be curious.
Yeah, no, it's a really great question. There are so many interesting research problems in this space that I've had to carve out, one place to start. But I think as vision and language kind of merge in models, like in the work that your group has published as well, we'll be able to generate at least text descriptions from vision a little bit. But the sort of, I guess it's kind of the frame problem is what you're pointing to. Like, how do you get all of the relevant information? I don't know. It's a very good question.
Yeah, very good question, and also perfect segue, because we're coming up against time, and this is maybe the opportunity for you to pitch something that you would like for somebody else to do. Normally I ask people, where can we find you, but you've helpfully put that on the slides. We also invite you to work from FAR.AI Labs for the day, meet people for lunch and dinner if you want to.
I'll be here.
Great. So yeah, is there anything that you'd be excited for people to do? Since you said there's so much out there, you don't have time to do everything.
Oh, for me to pitch ideas.
If
Great.
there's
Well,
something that you want other people to do, I'm not
goodness.
saying we have the capacity to do this. I'm saying maybe people are curious to hear.
The frame problem as was brought up. Gosh, I mean, I really, in general, yes, I would love for more people to work on the empirical characterization of LLM value functions. I think especially as your group has been doing, plugging them into real RL agents sort of is a good test bed for that. So so these action utilities, like how do they play out in the real world in RL type tasks, is a direction that I see as really promising. I would love for folks to try our annotator and help us develop it as well, because it's a tricky thing, and this could be a very useful tool. So we are very open to collaboration on any and all aspects of this project. And yeah, any of your feedback and conversations are really welcome. Yeah.
Okay, great. So for those of you who are wondering what to do for the rest of the day, there's something to do. Fantastic. Thank you so much for this great talk. And yeah, you said you'll be around for questions afterwards. So yeah, thanks, Anna.
Thank you so much.